Today we're going to continue using the PhET app. This time we're going to build a parallel circuit to measure current and voltage. So as before, I'm going to start the PhET app. I'm going to select the circuit construction kit for DC, select lab, and bring it up. As before, I'm going to turn on conventional current, turn on values, and let's get building our circuit. I'm going to bring a battery out. Drop it in here. I'm going to adjust the voltage to 10 volts. This is not the value that you're going to use, but I'm just doing this as an illustration. I'm going to scan down to the next menu to pull in resistors. I'm going to bring out two large resistors. 1,000 ohm, and the other one I'm going to make it 500 ohm. Tap on the resistor, set it to 500 ohms. Note how I have them laid out side by side. For a parallel circuit, I think this is the clearest way to see what's going on. Now we need lots of wires. I'm going to bring in some wires. So first wire, I'm going to make it nice and tall. You'll see why in a moment. I'm going to bring another wire in, have it sit right over top of the 1,000 ohm resistor. Drop a wire down to the 1,000 ohm. Use lots of wires. Don't be afraid to use plenty of wires here to make it look nice and clear. I've made this nice and tall on the top. I'll show you why in just a moment. So let's finish constructing our circuit. As before, you see when the circles touch, then you have the gray that indicates that you have a solid connection. There we go, everything's all set up. Now let's measure voltage. You see the 10 volt battery here. If I bring out the voltmeter, you'll notice this time anywhere I bring the voltmeter on, if I touch across a resistor, I'll see 10 volts. I can go across the 500 ohm resistor, I can go across the 1,000 ohm resistor. Anywhere we have a wire, we'll have the same voltage. So right up here on the battery, you see it's 10 volts, so let's get it on there. Yep, 10 volts. Even 10 volts across the resistor. It really doesn't matter where I put the two probes, as long as I have one on the high voltage side, one on the low voltage side, we will have 10 volt difference everywhere. Great. Now let's measure our current. As before, to measure current, we have to break the circuit. I'm going to measure the current individually through each of the resistors. I'll do that first. The 500 ohm resistor, I'm going to cut the wire, bring it down. I'm going to stick an ammeter right on top. The nice thing with the ammeters in this lab, it doesn't matter what direction you put them in. They'll read the same current either way. Reading 0.02 amps. If you use Ohm's law, you'll see that 10 volts over a 500 ohm resistor will give you 0.02 amps. Let's cut the next circuit. I'm going to bring in another wire here so we can make this guy work. I'll show you why in just a moment. And bring in an ammeter. Oops, let's get this straight. Gets a little clunky sometimes. Yeah, make it nice and tall. If you need to, make it even taller and bring it out. Because once they connect, then it's hard to line things up, get them nice and vertical again. There we go. That's pretty good. We'll go with that. Let's bring our wire down. Connect all the wires. Great. Now the 1,000 ohm resistor has 0.01 amps flowing through it. The 500 ohm resistor has 0.02 amps. If you recall, with a parallel circuit, the currents add. If I want to see the current coming out of the battery, let's grab one more ammeter and drop it in. There's no reason why you can't put in lots of ammeters to look at them all at the same time. If we were doing this lab, we'd be measuring them one at a time, so we'll take advantage of the fact that we're doing this on the computer. So here we go. Coming out of the battery, we have 0.03 amps, and that's the total current. 0.02 through the 500 ohm, 0.01 through the 1000 ohm. Add those together, you get 0.03. You'd also see if we put these on the bottom side of the resistors, you would see the same current flow on the branches. You can do it either way. There you go. So give this a try. If you have any questions, come back to me.